October 2025, every spacecraft orbiting Mars goes into alert mode simultaneously. An electromagnetic pulse erupts from interstellar comet 3I Gates Atlas, washing over the red planet with an intensity that triggers automatic safety protocols. The burst lasts 4.7 seconds, delivering more energy than 100 lightning strikes compressed into a single moment. This shouldn't be possible. The comet sits 8 million kilometers from Mars, far too distant for any known cometary process to affect another world. At that range, even a catastrophic outburst should barely register above background noise. Yet 3 different orbiters recorded systems overloading, instruments saturating, readings that make no sense. Within minutes, emergency telemetry streams toward Earth carrying impossible data. Not the random spherical expansion of a natural outburst, but something else. Something focused. Something that found Mars with precision across millions of kilometers of empty space. But how does a chunk of ice and rock generate that kind of power? And why aim it at Mars? The cascade of detection started with MAVEN, then rippled through every piece of hardware at Mars. At 14:47:23 UTC, MAVEN's magnetometer registered something extraordinary. Mars's weak magnetic field suddenly compressed, bending in ways that usually take massive solar storms to achieve. But this wasn't coming from the sun. 12 seconds later, chaos spread through the orbital fleet. Mars Reconnaissance Orbiter's radar went blind. Mars Express confirmed the impossible geometry, pinpointing the source exactly where 3I Atlas should be. Even Curiosity rover on the surface, protected by an entire atmosphere, detected the event through particle spikes that shouldn't have reached the ground. The synchronization defies coincidence. 5 different spacecraft, built by 3 different space agencies using completely different instruments, all seeing the same thing at the same moment. This wasn't an instrument glitch or calibration error. This wasn't space weather or solar activity. Something unprecedented had just happened at Mars. Every space agency scrambled to download data, to understand what their machines had witnessed. But the more data arrived, the less sense it made. Natural phenomena follow patterns, obey limits, respect the laws of physics. This event seemed to acknowledge none of those constraints, which raised an uncomfortable question that nobody wanted to ask first. The numbers tell a story of impossible precision. Total energy output, 10^18 joules, roughly equivalent to a major earthquake's power. But earthquakes release energy over minutes. This compressed similar power into 4.7 seconds and somehow kept it coherent across millions of kilometers. The internal structure makes even less sense. Engineers found a carrier wave at 8.4 gigahertz with harmonic frequencies following the Fibonacci sequence. Random cosmic events don't generate mathematical progressions. They don't maintain beam coherence, tighter than our best laser systems. They definitely don't show 97% circular polarization, a signature of engineered transmission. But here's where it gets truly strange. The burst pulsed exactly 47 times, each pulse lasting precisely 0.1 seconds. Between pulses, instead of silence, a carrier signal maintained at 5% intensity. This isn't the chaos of an explosion or the randomness of natural phenomena. This has structure, this has timing. This looks like something trying to be noticed. Conventional comet physics offers no mechanism for this. Sublimation doesn't create focused beams. Fragmentation doesn't generate mathematical harmonics. Whatever produced this burst operated by different rules. Rules we either don't understand or aren't natural at all. And the effects it had on Mars itself would prove even more disturbing. Mars lit up like a cosmic laboratory experiment. Auroras erupted across the northern hemisphere, not the dim glows Mars occasionally produces, but brilliant streams of green oxygen emissions painting the sky. The ionosphere went haywire, electron density jumping 50-fold in seconds, creating a temporary radio blackout that cut surface communications. The induced magnetic field around Mars did something remarkable. For those 4.7 seconds, the red planet had a magnetosphere stronger than its ancient dynamo ever produced billions of years ago. Field lines stretched thousands of kilometers anti-sunward before snapping back like cosmic rubber bands. Mars was responding to forces that had no business reaching it from 8 million kilometers away. Even the atmosphere changed. 3 hours after the burst, Mars Express detected a methane spike in the upper atmosphere. 400 parts per billion appearing from nowhere, then vanishing within one orbit. No known process connects electromagnetic bursts to methane production. Yet the timing suggests cause and effect that we simply don't understand. These weren't subtle effects requiring careful analysis to detect. This was Mars getting hit by something powerful enough to alter its entire electromagnetic environment. Whatever 3I Atlas unleashed had turned another planet into a resonating chamber for energies that shouldn't exist, but the precision of the targeting would prove even more unsettling than the power itself. The geometry screams deliberate action rather than cosmic coincidence. When the burst fired, 3I Atlas sat exactly 8.13 million kilometers from Mars, positioned at a perfect right angle between Mars itself and the Sun. This L-shaped configuration meant the beam traveled perpendicular to solar wind, avoiding the charged particles that would normally scatter electromagnetic signals. The window for this alignment lasted less than 8 hours. Mars's orbital velocity carried it through the beam path in exactly 4.7 seconds, matching the burst duration with millisecond precision. Earlier or later, by just hours, and Mars would have missed the energy cone entirely. The targeting accuracy defies random chance. But there's more. Trajectory analysis revealed something disturbing. 3I Atlas had been decelerating for 72 hours before the burst, experiencing a retrograde force that doesn't match any natural model. The deceleration ended 12 hours after the event, as if something had adjusted the orbit to achieve perfect positioning, then stopped once the task was complete. This isn't how comets behave. They don't time their outbursts to planetary positions. They don't adjust trajectories to optimize beam paths through solar wind. They don't calculate firing solutions across millions of kilometers. Unless, of course, they're not really comets at all. Which brings us to the failure of every natural explanation. The scientific community scrambled for explanations, but each attempt collapsed under scrutiny. Cometary outbursts were the first casualty. The most violent outburst ever recorded released 1,000 times less energy, spread spherically, not focused into beams that maintain coherence across planetary distances. Magnetic reconnection seemed promising until the numbers emerged. 3I Atlas shows no evidence of magnetic fields strong enough to store such energy. Even if it somehow possessed them, reconnection creates broad energy distribution, not surgical beams with Fibonacci harmonics. The physics textbooks offer no chapter for what we observed. Some proposed exotic scenarios, natural lasers formed by molecular excitation, charge separation creating space lightning, plasma phenomena we've never encountered. Each model captured fragments of the event, but required conditions that would destroy the comet entirely. Yet 3I Atlas continues on its path, intact, still following its trajectory as if nothing happened. The uncomfortable truth emerged slowly. No natural process in our understanding can produce focused electromagnetic beams of this power and precision from a comet nucleus. Either we're missing something fundamental about cosmic physics, or we're not looking at a natural object. The evidence increasingly pointed toward the second possibility, but that opened doors most scientists preferred to keep firmly shut. Even before the Mars burst, 3I Atlas had been rewriting the rules. Its spectrum showed nickel dominating iron by ratios that don't exist in our solar system. Carbon dioxide outgassing exceeded water by 5-to-1, completely reversed from normal comets. 3 discrete velocity changes at perfect 21-day intervals looked more like thrust events than random activity. The progression of interstellar visitors tells its own story. Oumuamua in 2017 showed acceleration without visible outgassing, sparking debates that continue today. Borisov appeared almost normal except for its hyperbolic origin. Now 3I Atlas combines strange properties of both while adding capabilities neither displayed. Focused energy projection across millions of kilometers wasn't on anyone's bingo card. History offers no true parallels. When comet Shoemaker-Levy 9 hit Jupiter in 1994, it produced electromagnetic bursts, but those were impact events, kinetic energy conversion. When Siding Spring buzzed Mars in 2014, it affected the atmosphere, but from 140,000 kilometers, not 8 million. What 3I Atlas demonstrated requires rewriting our understanding of what comets can do. The pattern suggests something troubling. Each interstellar visitor shows new capabilities, as if we're being shown a graduated demonstration. First unusual motion, then strange chemistry, now directed energy. If this is a progression, it's happening precisely when our technology has matured enough to detect it. Coincidence becomes an increasingly difficult position to defend. Data from Mars takes 18 minutes to reach Earth at light speed. By the time mission controllers saw the alerts, the event was already history. But the response was immediate. NASA's Deep Space Network reallocated 3 giant dishes to maintain continuous contact. In 72 hours, over 400 gigabytes streamed down, the largest concentrated data dump in Mars exploration history. Something strange emerged in the data handling. Raw files typically appear on mission websites within days. 2 weeks later, only processed, calibrated data had emerged. Mission spokespeople cited validation needs, given the extraordinary claims. But the selective release pattern raised questions. Several data packets showed corruption, information scrambled by the very phenomenon being studied. Some readings were lost forever. Behind the scenes, unusual protocols activated. The Chinese Tianwen-1 orbiter detected the burst, but that data remains classified. Unofficial sources indicate characteristics matching Western observations, eliminating any possibility of systematic error. When multiple space programs independently see the impossible, classification becomes the refuge of institutions that don't know how to explain what they've recorded. Public data that did emerge had gaps. Specific frequency ranges were missing. Certain timestamp windows showed redacted blocks. The official explanation involved corrupted packets and transmission errors. But the patterns of missing data seemed too selective, too convenient. What we're seeing might be everything, or it might be what someone decided we should see. And that uncertainty feeds into larger questions about how this changes everything. For 4.7 seconds, humanity's presence at Mars was vulnerable. Instruments exceeded design limits, communication systems went offline, navigation produced errors. If 3i Atlas could do this from 8 million kilometers, what happens when such an object passes closer? The question has space agencies quietly revising everything. Mission planning now faces a new category of threat. Solar storms were predictable, following cycles with warning signs. Interstellar objects arrive without warning, potentially carrying capabilities we don't understand. How do you shield against focused energy beams from objects that shouldn't produce them? How do you protect astronauts from phenomena that physics says can't exist? The Mars sample return mission underwent immediate review. Additional shielding might be needed. Launch windows might require adjustment to avoid potential encounters. Insurance adjusters started asking uncomfortable questions. Engineers began designing safeguards against events that weren't supposed to be possible. Planetary defense takes on new dimensions. We built systems to track asteroids that might impact Earth, but objects that can project force across millions of kilometers don't need to hit us to affect us. They just need to pass by. The Mars event proves that proximity alone carries risks we never imagined. The solar system suddenly feels like a much more uncertain place, and the window to understand these risks is closing fast. The fundamental mystery remains unsolved. What enables a comet-sized object to generate focused electromagnetic beams powerful enough to affect planets from millions of kilometers away? Every explanation requires either new physics or capabilities that transcend natural phenomena. Neither option is comfortable. The precision haunts every analysis. Why did the burst occur exactly when Mars would transit the beam? Why did it last precisely as long as that transit took? Why the mathematical harmonics, the circular polarization, the structured pulses? Random coincidence becomes increasingly untenable as the precision compounds. Yet the alternative implies intention, and intention implies intelligence. 3i Atlas reaches perihelion on November 29th. Between November 15th and December 3rd, solar conjunction blocks Earth-based observations. If more bursts occur, we might miss them entirely. We have perhaps 6 weeks before it escapes beyond detailed study, taking its secrets back to interstellar space. The pattern feels like revelation in stages. First, the impossible halo that ESA detected. Now, focused energy projection at Mars. Each event demonstrates new capabilities while maintaining just enough ambiguity to avoid definitive conclusions. We're being shown something, but shown in a way that lets us choose whether to see it. The universe just demonstrated that objects from interstellar space can reach across vast distances to touch our worlds. The question isn't whether it will happen again, but what happens when the next visitor arrives closer to home, and whether we'll be ready to understand what we're really seeing when it does.